Okay, so hello and welcome everyone. And in this video, I will show you how to apply DFS on a graph stored in adjacency list format. So first, we'll create a graph to store the edge and vertices, and after that, we'll apply DFS on it. So let me first create class graph. So we will use classes to store the graph. So I will name it graph. Okay. So now, okay, so what we public methods it will have are suppose int num vertices. So now, what other elements will it have? It will have adjacency list. So we will use adjacency list to store the graph. So adjacency list. So we'll make adjacency list using vectors. Okay, so now we'll name it adjacency list. Okay, so for this I'll have to include vector. Okay, now next thing I will need a visited array. So visited array is used to keep in track of which vertices we have already visited. Next I will define a constructor. Constructor will take an argument of number of vertices num. Now I am going to assign this num to number of vertices. Now what num is user will define how many vertices the graph will have, and according to what he assigns we will reassign the num vertices variable to it. Now the number of nodes is equal to number of elements we need to store in adjacency list. So we also need to resize the adjacency list. Then say list, we need to resize it to be num. Okay, we also need to resize the visited array. Resize. Okay. Now constructor is defined. Now second method we will be defining is how to add edge here. So user will give uv, that is u is connected to v, and since in adjacency list format if u is connected to v, then we will have to add adjacency list. In adjacency list of u we'll have to add v, and in adjacency list of v we need to add u. The reason being, if one is connected to 2 and 3, then in the adjacency list of 2 also we need to save 1, like 1 is connected to 2 and 2 is connected to 3, because it is an unweighted graph and non-directional. So let me just keep it here for reference. Okay, now the main part. Now these two things are done. We have created a method to add edge to the graph, and we have created a adjacency list to store the graph, and a visited array to keep in track of all the nodes we have already visited. So next is the main part. Now we will create DFS function. Now DFS function will take start. So at the beginning what we'll do is that first thing first, let's first make the start to be true. So now what this line is doing is that we are making the start to be true. Okay, so what this line means is that we are saying that we have already visited this node and we are not going to visit it again. So we are making the visited array of the start to be true. Okay, now this much is done. Now next part. Now DFS is pretty simple. In DFS what you have to do is that now you can print out the start. After you print out the start, we want to see all the neighbors, like after start all the neighbors of start. Now for visiting all the neighbors of start, this auto means it can be of any type. So let me name it as neighbor any, and it will come from adjacency list of any. So what this will give is that adjacency list of start. So here I will know all the nodes that are connected to start, and I will check if any is not visited, that is if visited of any is false. If visited of any is false, I will just call the DFS algorithm using any. Just these 2-3 lines and you are done with DFS. Now DFS any will be called with DFS, so first start will come, then its neighbors, then again it will keep on going. Okay, now we are done. Now we just have to add the edge, so let me create an instance of the graph. So graph G, and let me assign 5 nodes to it. Now let me call G with add edge. Add edge 0 to 1, 0 is connected to 1, G dot add edge, then 0 is connected to 2, then G dot add edge, 1 is connected to 2, G dot add edge, 1 is connected to 3. You can redraw this in your copy for your reference. 2, 4 and G dot add edge of 3, 4. Okay, so now we are done. Let's try to run it and debug if there are any errors. So there are many errors. First, I think I have called acha, I am not using namespace, using namespace std. Okay, now I need to call the function. I didn't call the function, sorry. G dot EFS, and I want to call it from the start, that is from 0 I want to call it. So okay, now it's working. So first it visited 1, then after first 0, then 0 is connected to 1, then after 1 is connected to 2, then 1 is connected 2 is connected to 4, then 4 is connected to 3. Okay, we are getting the DFS here. So now I will explain each and every line of this code so that it is easier for you to understand. So what we are doing here is we are storing graph into adjacency list format. So there are 2 ways to store a graph. First is adjacency matrix and second is adjacency list. So in this specific problem we are using adjacency list. So we are using adjacency list here. So in adjacency list, elements are stored in this way. Suppose 1 is connected to let me see, 1 is connected to I will explain it in the bottom. So here let me explain you how the adjacency list is stored. Now 0 is connected to 1, 2. Okay, now 0 is connected to 1, 2, 1 is connected to 2, 3, 2 is connected to 4, and 3 is connected to 4. Okay, so adjacency list is stored in this format. So here 0, 1 is going and it goes to add edge format. Now in here 0 is coming and here 1 is coming. So in adjacency list of 0 we are adding 1, and in adjacency list of 1 we are adding 0. So okay, so some other things also I need to do. 0 is connected to 1, so 1 is also connected to 0. 0 is connected to 2, 2 is also connected to 0. 0 is connected to 1, 0 is connected to 2, 1 is connected to 0, 2 is connected to 0, 1 is connected to 2, 2 is connected to 1, then 1 is connected to 3, 3 is connected to 1, 4 is connected to 3. Okay, so in this way it's basically stored. So 1 is connected to 3, 3 is connected to 1. Okay, so this is how it is stored. So let me just comment it. So this is the main function of add edge. So it's adding the edge, like to u it's adding v and to v it's adding u. Now the main part, the DFS part. Now to understand about DFS. Whenever you hear the word DFS, think about stack. Now in DFS it uses stack. Now you will say that we are not using any stack here, we are using the function stack here. What we are doing is that we are calling it recursively, so we are using stack, that is function stack. So here what's happening is that we are starting from a starting node, then we are making the visited of that start to be true, that is we are marking that we have visited here and it's already visited. If you come across this node again, don't visit it. Second is we are printing start, that this is visited, we have start. Now we are checking all the neighbors of that start. Now all the neighbors of that start are stored in adjacency list of start in here. Now we are checking all the neighbors of that using any variable. Now what we are doing is that in this line we are checking, suppose here 0, after 0 its neighbor is 1, we are checking if visited of 1 is true or not. Obviously it's not true because it's the first iteration, so we call DFS of 1. So when we call DFS of 1 is printed, then after that again after 1 is printed we come here. Now the neighbors of 1, now the neighbors of 1 is 0, 2, 3. So first 0 is checked, it's already true, we marked it in the first iteration. Now 2 comes, now visited of 2 is false. Now for 2 we are calling, now we get 2. In this way all the nodes are called and we get the DFS of this graph. Hope this video helped you.